Hey Chem Kids, Campbell here. In this video, we're going to do something a little tough. We're going to balance redox reactions. Now the method I'm going to show you is using the half reaction method. And we're going to focus on only acidic solution balancing. There's also basic solution. There's also other methods to doing this, but I found that the half reaction method works best in regular chem. But you want to learn another type? Go to YouTube. There's plenty of different videos on balancing redox reactions. So first I'm going to go through just a summary of what you're going to see in this video, and then we're going to do it together. So first thing we're going to do, half reaction method, is divide our reactions into half reactions. So we're going to take this whole reaction and we're going to split it in half. Then we're going to balance the number of atoms, similar to what you've done in the past, except there's going to be a new little twist there. We're going to balance charge. We're going to do that by adding electrons, because remember, redox reaction, oxidation reduction is about the transfer of electrons. Then, if the number of electrons that we've added to balance our half reaction charge are not the same, so if one has a different number of electrons than the other, then we're going to have to multiply one or both of those half reactions by a whole number so that the number of electrons in both half reactions are the same. Then we're going to simplify them and put them back together. So let's start this very long journey together. So here is a first example. We're going to use chromate. Now you can ignore all the aqueous symbols, and you're going to see another one in the future with liquid symbol. All we're going to do is look at the atoms and their charges. So we're going to split these in half first. That's our first step, by taking the stuff that matches in the reaction and pulling it out. So the chromium matches on both sides. So we're going to write Cr2O7 minus 2, and don't forget that charge. I always write it this way. I never write it 2 minus. And then the other matching thing for my chromium is this Cr plus 3. So you take the stuff that matches and pull it out and make it its own little reaction. My other half reaction involves the iodine. So I'm going to write that down, I minus arrow I2. So those are my half reactions. Take the stuff that matches and pull them out and put them in their own little half reaction. Next thing we're going to do, so write this down, is balance all the atoms except hydrogen and oxygen. We're going to do that by adding coefficients, just like you did last semester when we learned how to balance reactions. So if I look here, I have 2 chromium here, but I only have 1 chromium here, right? There's no little subscript down here. The charge doesn't count as a number of atoms. So that means I'm going to have to put a 2 in front of the chromium. So I have 2 chromium on this side and 2 chromium on this side. Now, I know I have 7 oxygens, but remember, we're not going to deal with these guys right now. So I'm going to go to my next half reaction. I see I have 1 iodine and I have 2 iodine on this side. So I'm going to put a 2 right there. So now my iodines are balanced. Now we're going to deal with the oxygens and the hydrogens. So what we're going to do is anytime there's an oxygen, we're going to add water to the other side of the reaction to balance it. Then we're going to go back and balance the hydrogens from that water that we added by adding H+, or if there happens to be hydrogens in the reaction, we're going to add H+. So let's go back up to this reaction, because we had 7 oxygens here. So that means I need to add 7 waters, because every water has 1 oxygen. So we're going to add 7H2O. Now you'll notice there's no oxygens in here or hydrogens we have to balance, so we can forget about this one for the moment. And we're going to go back now. And because we added this water, now we have hydrogens, and we're going to balance them, because this is acidic solution, by adding H+. Make sure you put that plus in there. So 7 times 2 is 14. So I'm going to add 14H+ over here. Now, if we look, we have 14 hydrogens here. 7 times 2 is 14 hydrogens here. We have 2 chromium, 7 oxygen, 7 oxygen. And down here I have 2 iodine and 2 iodine. So atoms, check. All right. Now we're going to balance the charge. So remember that electrons are negative. So what we're going to do, and these are redox reactions, so electrons are moving in the reaction, we're going to balance the side that is more positive by adding electrons to it. So you're probably like, what do you mean more positive? Well, what we're basically going to do is add together all of these little charges that we have, but we have to multiply by how many we have. So I have 14H plus, which means I have 14 positive charges over here. So this is plus 14. Here I only have one of these, right? If there's no coefficient here, it just means there's one. And it's at -2, so I'm going to add a -2 or subtract 2. So my total charge on the left side of this arrow is plus 12. Now, this has to equal the total charge on the other side. So let's see what we have on the other side right now. So I have 2 of these plus 3s, so that'd be 2 times plus 3, which would be plus 6. And notice that, and again, forget about that stupid liquid sign there. Notice there's no charge here. Water is a neutral substance. It never has a charge, so that's going to be a 0. So that means that my total charge on the right side is plus 6, which does not equal my total charge on the left side, which is plus 12. And it should always be that way. They should never equal, right? We need to add electrons. This is an oxidation reduction reaction. So what we're going to have to do, remember that we're going to add them to the side that's more positive, because adding electrons is like subtracting, right? Electrons are negative. So if I want this side to be plus 6, right, I want to subtract 6, right? 12 minus 6 would be plus 6, and then these sides would be equal. So that means I'm going to add 6 electrons to the left side of that reaction, because electrons are negative. So 12 minus 6 is plus 6, the other side is plus 6, and now my charge is balanced because electrons are negative. All right, if we go down to this reaction, this is a -1. I don't know why the arrow got so close to it. So I have 2 times -1, so that's -2 on that side. On the other side, this has no charge, right? There's nothing up here, so that's 0. Now, -2 does not equal 0, right? That is not true. So we need to add electrons to the side that's most positive. So because the other side is negative, 0 is my most positive number, right? If I subtract 2 from 0, I'll get -2. So then my charges would be equal. So I need to add 2 electrons to the right side of this equation because electrons are negative. Now, one of the things that you need to check, because in an oxidation reduction reaction, somebody's losing electrons and somebody's gaining electrons, you have to have your electrons on opposite sides of your half reaction. So if they're in the reactant side of one, they have to be in the product side of the other half reaction. Or if they're on the product side of the first reaction, they have to be on the reactant side of the second reaction. They have to be on opposite sides. So if you end up adding electrons to the same side, like the reactants, or you add electrons both to the products, something's wrong and you need to go back and start over. I know, it's a lot of work to start over, but you have to start over. All right, now remember I said that the number of electrons given has to be the same as the number of electrons received. Well, 6 and 2, not the same number. So I need my second reaction to have 6 electrons. And fortunately, 2 goes into 6. Since there are 2 here and there are 6 here, 2, if I multiply this entire reaction by 3, right, 3 times 2 is 6, I'll have 6 electrons in my second reaction. Now, you can't just multiply the electrons, you have to multiply the whole reaction, every single thing. So I'm going to do this down here. 3 times 2 is 6i minus. Then we got our little arrow. 3 times 1, right, if there's nothing here, that's just a 1, not a 0. So that's 3i2. Plus 3 times 2 is 6 electrons. So now I have 6 electrons in the first reaction and I have 6 electrons in the second reaction. We are good now for our very last step, which is to simplify and combine. All right, so here are those reactions. What we're going to do is we're going to simplify first. I like to simplify first, and then we're going to put them back together. So what you're going to do is you're going to look at the the reactants in the first reaction and compare them to the products in your second reaction and look and see if anything's the same. If we look here, we see we have 6 electrons in the reactant side of the first reaction and 6 electrons in the product side of the second. So we're just going to cross those out. Those are going to cancel each other out. Now, if I look, these guys, there's nothing that looks like that over here. They have to be identical. And then we're going to go to the product side of the first reaction and compare it with the reactant side in that second. And you'll notice, again, there's no similarities. Things that would be similar, things you'd be simplifying, are things like hydrogens and waters. And when we do our second example, you'll see what I mean by that. So now I have nothing in common with both reactions. They're all different. Everything on here is different. So we're going to just add them together now. So we're going to take everything on the left side and put it on the left side of the arrow. And we're going to take everything on the right side and we're going to put it on the right side of the arrow. So we're going to write this stuff down. So we have 14H plus. My next thing is that Cr2O7 minus 2. I get to the arrow, so I'm going to drop down to this reaction down here. And we're going to add 6I minus. I get to the arrow, so now we're going to add our arrow. Go back up to the top. 2Cr plus 3 plus 7H2O. And then we drop down here and we add our 3I2. All right, so we're done, but always do a final check of your atoms and charges. Very important. If you do that, you're guaranteed to do this right. Maybe, I don't know. So what do I mean by that? We're going to first check all our atoms. So I have 14 hydrogens here. I want to make sure I still have 14 here. 7 times 2 is 14. Hydrogen's good. 2 chromium, 7 oxygen, 7 oxygen, 6 iodine, 3 times 2, 6 iodine. Atoms, check. Now we're going to check the charges and make sure the total charge on both sides are the same. So on this side, I have plus 14, right? 14 plus 1s. I have 1 minus 2, and I have 6 minus 1s, so that's minus 6 total. So that'd be 14, that'd be 12, so that's going to be plus 6 on the left side. That needs to be equal to the total charge on the right side. 3 times plus 2, that's plus 6, right? 2 times 3 is 6. These guys have no charge, so each of those are 0. All right, plus 6 charges are balanced. Boom, we are good. All right, how you doing? Now, if you think you're good, go ahead and do the next one by yourself. If not, follow along with me. We're going to do another one together. But just to review, half reactions, balance all atoms but hydrogen and oxygen. Then balance oxygen with water and hydrogen with H+. Balance charges by adding electrons. Then if your number of electrons in your half reactions aren't equal, you're going to have to multiply one or both of those reactions by a whole number to make them equal. Then we're going to simplify and we're going to put them back together. And then we're definitely going to do the check at the end of all the atoms and charges, right? Right. All right, let's do this. Now, when I usually do these, instead of doing one on top of the other like we did in that last reaction, I usually divide my paper kind of in half. And then I put one half reaction on one side and one half on the other side. It doesn't matter how you do it, top, bottom, side, whichever works for you the best. The problem you have to be careful about if you do it like I'm going to do it now is you have to make sure you leave enough space to add your waters and hydrogens and electrons. So let's do this. So I have MnO4. One of my half reactions, right? First step, do your half reactions. And then the other part of this half reaction is going to be that MnO2. All right, and my next half reaction is that C2O4 and the carbonate. So we have C2O4 minus 2 and our carbonate. So we're going to match our carbons together and we're going to match our manganeses together. All right, next step. Step 2, balance all atoms that are not oxygen or hydrogen. So if I look at my first one, right, there's just one manganese on both sides, and then I just have oxygen. So let's go over here. You'll notice here I have 2 carbons, but carbonate only has 1. So that means I need to put a 2. I should have left myself a little bit more room. A 2 right there. Now I have 2 carbons. And again, we got oxygens. So all my atoms now are balanced that are not oxygen or hydrogen. So let's now deal with oxygen. So remember, we balance oxygen by adding water. So I have 4 oxygens on this side and only 2 here. So that means I need to add 2 waters. All right, each water has 1. I need 2, so we're going to add 2. I'm going to go over here and balance our oxygens, then we'll come back to hydrogens. Here I have 4 and I have 2 times 3 is 6. So I have 6 oxygens on the right side, and I only have 4 here. So I'm short 2, right? 4 plus 2 is 6. So then I'd have 6. So we need to add 2 waters on this side as well, 2H2O. All right, so now our oxygens are balanced, and we need to go back now and balance our hydrogens. By adding 2 waters, I added 2 times 2 or 4 hydrogens. So to this side, I need to add 4H plus. Again, don't forget the plus. It's very important when we do the charge. And over here, because I added 2 waters, just like on that other side, I need to add 4 hydrogens here, right? 2 waters. Each water has 2 hydrogens, so 2 times 2 is 4. So I need 4H plus. All right, now if we look, 4 hydrogens, 1 manganese, 4 oxygens, 2 plus 2 is 4 oxygens. Over here I have 4 hydrogens and 4 hydrogens, 2 oxygens plus another 4, so that's 6 oxygens. 2 times 3 is 6 oxygens here. Oxygens are good. 2 carbons, atoms, balanced, check. Now what do? Now we got to balance charge by adding electrons to the more positive side. So let's see what we got. Here I have 4 plus 1s, so the hydrogen is contributing plus 4. I only have one of these MnO4 minus 1s, so that means I just have 1 minus 1. So my total charge on this side is plus 3. That has to be the same as the charge on this side. The charge I have on this side, neither of these have charges, right? There's no charge up here. I didn't forget to bring it down, which can happen. No charge there, so both of these are 0. Why did you do that? Both of these are zeros. So I have a total charge of 0 on the right side. I have a total charge of plus 3 on the left side. So in order to make these equal, right, I need to subtract 3. We always add electrons to the positive side. So that would make it 0. So that means I need to add 3 electrons to the left side of that first half reaction. Now my charges are balanced. I have a total charge of 0 on this side and a total charge of 0 on that side. Now let's go to our other half reaction. On this side, I have that water never has a charge, so that's 0. And I only have one of these guys at -2. So my total charge on the left side of this reaction is -2. That needs to be equal to the total charge on this side. So I have 2 times -2, right? 2 times -2 would be -4. 2 times 2 is 4, and that's negative. And this is plus 4. So my total charge on this side is 0. My total charge on this side is -2. So I need to add the electrons to the side that's more positive. So in order to do that, it's like subtracting numbers, right? So that would give me a -2 on this side, and it would be equal to the -2 on that side. So that means I need to add 2 electrons. Now, before we go on, let's just make sure that in our half reactions, they're on different sides. So if I look at my manganese reaction, notice that my electrons are on the reactant side, or the left side of the arrow. And if I go to my other half reaction, my electrons are on the product side, or the right side of the arrow. Whew, they're on opposite sides. They need to be that way. So if they end up on the same side, go back and figure out what you did wrong. All right, unfortunately, 3 and 2 are not the same. Remember, our next step is to make sure the number of electrons we add to both half reactions is the same. And 3 and 2 are not the same, and 2 doesn't go into 3 this time, like it did with 6. So that means I'm gonna have to multiply both of these by a number that will make those numbers the same. So the least common factor is I'm just gonna have to multiply them by each other. 3 times 2 is 6. So we're gonna need to have 6 electrons in both of these. That means I need to multiply this reaction by 2, right? Because 2 times 3 is 6. And I need to multiply this reaction by 3, because 3 times 2 is 6. So that's the best we can do. So sometimes you'll have to multiply both reactions by a number so we can get the same number of electrons. All right, and remember, you got to multiply everything. So 2 times 3 is 6 electrons. 2 times 4 is 8H plus. 2 times 1 is 2. Let me just try that again. Is 2 MnO4 minus arrow. 2 times 1 is 2 MnO2. 2 times 2 is 4 H2O. And now let's go to this one. 3 times 2 is 6 H2O. 3 times 1 is 3 C2O4 minus 2, arrow. 3 times 2 is 6 carbonates, CO3 minus 2. 3 times 4 is 12 H plus. 3 times 2 is 6 electrons. Woo, barely made it. It's one of the problems with putting them side by side. You got to write small. Whew. Okay, so now we have 6 electrons in both of our reactions. So now it's time to simplify and then recombine. So we're going to start with our reactant side of the first reaction. So we have 6 electrons, and we go to the product side of our second reaction. We see 6 electrons, and so we're going to cancel. Electrons should always, always, always cancel. If they don't, again, go back and figure out what you did wrong. Now we're going to look at hydrogen. So this time, because I added hydrogens to the other one, we have hydrogens to cancel. So I have 8 hydrogens here, and if I go to the other side of the second reaction, I have 12. So what we're going to do is we're going to subtract 8 hydrogens from both sides. If I do that, that becomes 0. If I subtract 8 from 12, right, I get 4 hydrogens. I'm going to put a line through them. That way I don't mistakenly put them back into the reaction. That happens. There's so much going on here that it's easy to make little tiny mistakes. Okay. Manganese, don't have to worry about that in the other half reaction. So now we're going to go to the product side and look at the reactant side of our other half reaction. Again, we're not going to see manganese in the other reaction, so you can just skip that. But water, notice I have 4 waters in the product side of this one, and I have 6 waters in the reactant side of this reaction. So we're going to simplify by subtracting 4 waters from both sides. So that gives me 0 waters in this one, and I subtract 4 waters here, and that gives me 2 waters in that one. Whew. Let's recombine now. Everything on the left side goes on the left side. Everything on the right side goes to the right side. All right, so we got rid of all that stuff. The hydrogens and the electrons are gone. So we're going to start with 2MnO4 minus. We get to the arrow, so we're going to jump over to this side, and don't forget these little 2 waters here, plus 2H2O plus 3C2O4 minus 2. Now we get to the arrow, so we can go back over here. 2MnO2. Okay, we got cross those out. So we can go over to this arrow, and we have 6CO3 minus 2, and we have 4H plus. All right, now that's supposed to be an H. Before we say we're done, we're going to just check our atoms and our charges. So we have 2Mn and 2Mn. We have 8 oxygens plus another 2, so it's 10. Whoa, plus another 12. So that's 22 oxygens on this side. We better have 22 over here. 2 times 2 is 4. 3 times 6 is 18. So that's 22. We have 22 oxygens. Whoa, that's a lot of oxygens. All right, oxygens are good. We have 2 times 2 is 4 hydrogens, 4 hydrogens. We did oxygen, so I can skip that one. 3 times 2 is 6 carbons, 6 carbons. Whew, atoms, you are check. Now, charge. We have -2 plus, there's no charge here, water's always 0. 3 times a -2. Right, 3 times 2 is 6, so that'd be a -6. So my total charge on this side is -8. Hopefully it's the same over here. This is 0. 6 times a -2. 6 times 2 is 12. Right, so that's a -12. And then we have +4. So that would be -8. Yay, -8, -8. Charge is check. Whew. I know, it's a lot of work. How'd you do? So this is good. We are good to go. You want to do another one? I'll let you try this one for real, and then check and see if you got the right answer. So pause the video, see if you can do this one by yourself. If you did this right, you should have 3SO3 minus 2 plus 2H plus 2NO3 minus 1 yields 3SO4 minus 2 plus 2 NOs plus 1 H2O. How'd you do? Now, one thing, if you messed up, a lot of times that happens right here because you needed 3 oxygens and you already had 1. So you only needed 2 waters. Sometimes people will write 3H2O, forgetting that this counts as 1. So maybe that's where you messed up if you made a problem. Otherwise, see if you can work through this and figure it out. And if not, ask me in class. All right, I'll see you in class.